Okay, so let's look at an example of a scoring model. And this is a scenario where a gentleman named John Harris is thinking about purchasing a new Harley Davidson motorcycle, and he's narrowed his choices to one of three models: the Sportster Classic, the Heritage Softail, or the Electric Glide. So he also then identified his decision-making criteria, the things that were important to him. For instance, what was the wind protection like on the design? What was the fuel tank capacity? How comfortable was it for passengers? What's the seat height? What was the acceleration, and so on. And then he identified how important each of these criteria were on a 1 to 5 weighting scale. So, for instance, wind protection got a great big importance from him. It was more important, much more important than passenger comfort. He was less concerned with that. Then he in turn went and identified how each option performed on a 10-point scale in this case relative to those criteria. So for example, for the wind protection, the Sportster Classic may not have had the wind protection design that the Electric Glide did, and he gave that a much higher score for that criteria. So in this case, he's got 7 criteria, 3 choices. We have 21 different elements here that came into the weighting factor. So in this case, since I've given you the criteria, I've given the weighting, we've given the ranking, and so on, those are steps 1, 2, and 3. You only need to execute steps 4 and 5 for the sake of completing this question. So the question asks you, using the scoring model, determine the recommended motorcycle for John, which model. So there will be a similar question on test 5, and there are Excel file templates on Canvas in module 7 associated with this. So how do we come to an answer? All right, I've given you 2 methods here. Manual method, and this is a screenshot from the answers posted on Canvas, and SC, Sportster Classic, so on and so forth. So what we did was we took each weighting factor by the time, multiplied it by the performance. So let's take a peek back at that again. In the terms of the Sportster Classic, for the wind protection, weighting was 5, performance was 3. Fuel tank, weighting was 3, performance was 5. See that here, how I'm going through? Repeat that for 7 factors. Do the math, multiplication, then addition. We get a total score in that case. So in that scenario, the Electric Glide scores 137, which is the highest. Therefore, that would be the recommended alternative. You can do it that way if you wish. Also recommend you use an Excel file. There's a template that I've posted on Canvas, and that template looks like this, where you enter the criteria and you enter the weightings and so on. I'm just entering some simple values here, and then you decide how each of these scored, and then numbers start to develop, and we have the solution here. But I've already done this, and on another file I entered the criteria, I entered the weighting, I entered the performance parameters. These are green, these are student entries, so I've given you this template. If you were to be posed this type of problem in a test, you would have to enter the data in the green cells in order to arrive at what would be the scoring and the solution. And in this case, we get the same numbers as when I did the manual solution, and the alternative 3, which is actually the Heritage Sport. What was that? Actually, that was the Electric Glide, forgive me. And that would be the choice of which one should be John's solution. So we had the Sportster Classic, Heritage Softail, and the Electric Glide. So that's how you would use Excel to solve this type of problem. I'll give you some more examples, and this should be pretty straightforward for you to do. Be prepared for a question on the test associated with this chapter. Okay, we're going to go to the next and final technique, which is the most robust, also a bit the most complicated, and it's a multi-stage consideration where we identify the importance of potentially conflicting criteria and I've used this in the real world, and it's something that can be very powerful. It's also very complicated for people to understand. So I'm going to quickly explain to you the steps. These are reflected in our text on these pages. The steps are, again, similar to the scoring model. We have to have the goal, the criteria, the alternatives. Then we develop something that's different. We didn't do it with the score model. We developed what's called a pairwise comparison matrix. And this is where we list the alternatives relative to each other. And you're forced to compare the preferences, say for that Heritage Softail versus the Electroglide, and so on. You're forced to compare them to each other, which gives us the chance to look at things in a more direct comparison. And so we'll give that, we do that pairwise comparison matrix conclusion. We compare one alternative against another. Compared to the second alternative, the first alternative is what? We give it a scale in some fashion. In this case, this example is a 9-point scale. And then we take something, when we do a comparison, we do reciprocal ratings. That is, if alternative 1 is given a 9, then compared to that, the second alternative is the inverse of that. It's 1/9. That's what we call the reciprocal rating. So when we complete a pairwise matrix and we compare an alternative to itself, we always give a value of 1. Again, I'll give you an example. From this point forward, we develop matrices and vector analyses, and I strongly recommend you let Excel do the heavy lifting. You can do it manually. I've given you some examples in PDF file where you can see how it's calculated manually, but it's very intricate and detailed and increases the probability of making an error. And if you use the templates I provided, you're less likely to make that error. Now, lastly, when we want to calculate something we call the consistency ratio, that is, are we made sense when we compare the two choices, when we do that pairwise matrix? And if we have a low value for the consistency ratio, less than or equal to 0.1, and we say that our comparisons are consistent between one another. For instance, if I say option 1 is more strongly preferred, let's say with an 8 or a 9 compared to option 2, and then I compare option 2 to option 3. Option 2 is more strongly preferred compared to option 3. Then in turn, when I have to compare 1 to 3, I have to make sure that that comparison is even stronger yet. In other words, I couldn't have a weak comparison there. So we need to look at that, and there's some argument in the literature with regard to what level of CR 0.1 is a threshold, but for our sake, we're going to go along with that. And if we have a CR less than or equal to 0.1, we say that the matrix seems consistent. And if it's higher, we say it's not consistent. So something we do in terms of the calculations on these different steps, we calculate something called the consistency index. Again, Excel can do this for you based on the random index value, and these are fixed values based on the number of alternatives. We're going to stick with 3 or 4 alternatives, and then we plug this value in. And the consistency ratio is the ratio of the CI to the RI. Let me tell you just quickly about a real-world application of something I did not long ago for a client. We had in this case 6 criteria with 6 courses of action, we call them, COAs. And in turn, this is the pairwise matrix we developed. This was just a table to remind us of the RI value. And we used a 9-point scale in terms of relative comparison for them. This was rather complicated. We had a multi-stage, multi-sheet Excel model, and it took us quite a while to explain this to the client, but it was very powerful in trying to understand the different options and giving us a ranking of which course of action, this was a software project, which course of action would be most appropriate. So it does have real-world application. All right, let's look at this one particular example, and this is indicative of how I will present problems to you on a test. So in a test I will give you something like this, where I give you a matrix. This is a 4 by 4 matrix. So in this case, it's a 4 by 4 matrix. We have 4 options, models A, B, C, and D, and then we complete that matrix here. Some elements I will complete for you and just ask you to finish off, complete the matrix, and then I'll ask you to compute the consistency ratio and to determine whether or not it seems to be consistent. And I want you to recognize that those are the Excel templates based on either 3 by 3 or 4 by 4 given you. Matrices are provided on Canvas. This would be a 4 by 4 model. So let's look at how this would complete. Now you're going to do the matrix, complete the matrix either manually, or you may want to complete it manually first, or certainly you're going to get to use it in Excel. So what's the best answer? So in terms of a manual method, here's what it would look like. And I've got the 4 options listed here. The circles are those cells that were blank and that you had to solve for. And I gave you the rest of these. So let me pull this larger. So I mentioned previously that all options compared to itself is a 1. So model A compared to the model A is 1. B compared to B is 1, so on and so forth. That usually forms on the diagonal of the matrix. So let's look at one example in terms of completing this matrix. We had a blank cell here, right? Notice we had the blank cell here in this upper right area. So model A, how much is model A preferred compared to model C? Well, when this was blank, the way to figure out what this should be is to look at how does model C compare to model A. Model C compared to model A is 1/4, or it's less preferred, if you will. Therefore, model A compared to model C, which is the inverse of that, would be a 4. This cell here, let's work on completing this. Model B as compared to model C. Well, let's look at how model C compared to B, the inverse. That value was 1/3. Therefore, we take the inverse of 1/3 and we yield a 3. Let's look at this cell. Model D compared to model A, the intersection of those two. Well, how did model A, let's flip that. How did A compare to D? A compared to D was 1/6. Therefore, this cell, D compared to A, would be the inverse. Let's look at D compared to B. Well, to solve that, we would have to see, well, how did B compare to D? And that was 1/2. Therefore, this would be the inverse. Similarly here, the last cell, C compared to D. If we compare, then we'd have to find, well, how did D compare to C? That was 1/4. Therefore, this would be the inverse. So it's pretty simple, straightforward logic. I hope you follow that. I'll give you some more examples. But I do recommend you use Excel. Use the file based on the size of the matrix, whether it's 3 by 3, 4 by 4, and so on. So the files are posted on Canvas. Now let's show you what this looks like in the real application using Excel. So what I did here, I completed this already, entered model A data. Green here would be the student entries. Everything else are calculated values. This is where n equals 4, the number of choices. And so I entered data here, model A, B, C, and D. I entered the matrix data here. So for instance, when I had a 1/6, I simply entered the value here in Excel equals 1 divided by 6. Once I complete the matrix here, everything else automatically calculates for you, all the steps. We get the CI, and then in turn we get the CR. Now something you need to potentially make sure of, we make sure we have n equals 4. That's how many choices we have. Make sure our index here is equal to 4 in this case, pardon me, 0.9, just as I showed you back here. All right, so our random index number, when we have 4 alternatives, we have a random index fixed value of 0.9. And from that, our CR will calculate, and our CR in this case is 1.17. So answer yourself the question, if a CR is less than or equal to 0.1, it yields a yes answer, that it seems to be consistent. In this case, 1.17 is certainly much greater than 0.1. No question about that, it's not even close. Therefore, we say in this case that the matrix is not continuous.